In question 2, we have a student adding masses to a spring and measuring the extension. In part A, we have to complete the table. Well, the table needs a heading, and it is the extension in centimetres. And what we need to do is take the original length of 12 centimetres from each of the new lengths. And so the initial length with no mass, 12 centimetres minus 12 centimetres, is 0 extension. 13 minus 12 is 1 centimetre, and 13.8 minus 12 is 1.8 centimetres. For B, we then need to add these to the graph. So the graph would go something like this. We need to label the y-axis as extension in centimetres, and we can go up in halves. So if we go half 1, that takes us up to 5 at this point. So that would be 0.5, 1.0, and so on. And you get a straight line going through the origin, something like this. And for part C, we need to find the gradient. Well, I got the change in y to be 5.15 times 10 to the minus 2 meters, and the force, change in force, to be 2.75 newtons. That gives a gradient of 5.15 times 10 to the minus 2 over 2.75 gives 0.019 meters newtons to the minus 1. We then need to find the spring constant K. This is part D. Well, K is basically force over extension, which is 1 over the gradient, which then is 1 over 0.019, coming out at 53 newtons meters to the minus 1. In part E, we're to state and explain whether the graph shows that the spring combination obeys Hooke's law. Well, the graph is a straight line through the origin, so it does obey Hooke's law, which states that extension is directly proportional to the force as long as the elastic limit has not been exceeded. In F, we have to determine the ratio K3 with 3 springs over K2 with 2 springs. Well, K, or K1, with 1 spring would be the force over the extension. With 2 springs, for the same force, we'd have twice the extension. So we can say that K2 would be the force over twice the extension. Both springs would have the extension that the individual spring would have. And then K3, taking this one step further, would have the same force but would give 3 times the extension. So we want K3 over K2. This is F over 3e divided by F over 2e. Divided by a fraction, we times by the inverse of the fraction. So F over 3e times 2e over F. The F's cancel, the e's cancel, and we're left with 2/3, or 0.67.